For this question, we're given the logistic model, dp dt, the rate of change of population equals kp times max minus p, which means it varies jointly with the population and the difference between the population and the maximum possible population. We're told max is 1,000. We're told p of 0 is 5 and p of 1 is 8. So let's collect all that information as best we can. Again, our differential equation, dp dt is kp max minus p. And what do we know? We said max was 1,000. That enables me to start with my differential equation. dp dt is kp times 1,000 minus p. And then we have other information that they gave us. We said p of 0 was 5. So that's the initial population was 5. 1 unit later, maybe 1 day later, there's now 8 individuals. We want to find p of 2 after we solve the differential equation. And we want to find out when is p greater than 900. The max is 1,000. How far do we have to go to get p greater than 900? Okay. Well, first off, this is a separable differential equation. We're going to get all the p's on one side and all of the t's on the other. So we're going to say dp over p times 1,000 minus p equals dt. So we have successfully separated the variables with a k as well. Integrate the left side, integrate the right side. But the left side is going to require us to do a partial fraction expansion. And the right side is just kt plus c. So the right side is easy. Let's go ahead and do that. The right side is just kt plus c. But let's take a look at that left side. So what is the left side? We have the integral of 1 over p times 1,000 minus p dp. So using partial fraction expansion, a over p plus b over 1,000 minus p equals 1 over p times 1,000 minus p. So we get a times 1,000 minus p plus bp over p times 1,000 minus p equals 1 over p times 1,000 minus p. You say at this instance, the bottoms are the same, so I make the tops the same. A times 1,000 minus p plus bp equals 1. But what is 1? Because here I have 1,000a minus ap plus bp. So 1's a little troubling, but 1 is actually 0p plus 1. That will enable you to solve those equations. So as far as the 1 part, 1,000a has to equal 1. So we'll write that down. 1,000a is 1. And then negative ap plus bp has to equal 0p. Negative ap plus bp is 0p. Well, let's divide by p. I'm not concerned with p's right now. So negative a plus b equals 0, which means b equals a. Okay, well, I have a. If 1,000a is 1, a is 1 over 1,000. And if b equals a, b is also 1 over 1,000. So where does that put me? This integral on the top up here is a over p, so 1 over 1,000 over p. Over 1,000 over p dp. plus b is also 1 over 1,000. 1 over 1,000 over 1,000 minus p. So that is our partial fraction approach to this. So you can go back to our first page and recognize that. So I'm going to rewrite this as 1 over 1,000 times integral of 1 over p dp plus another 1 over 1,000 times the integral of 1 over 1,000 minus p dp. So let's clean that up a little bit. Where are we at? 1 over 1,000 integral 1 over p dp plus 1 over 1,000 integral 1 over 1,000 minus p dp equals, the right-hand side was kt plus c. Integral of 1 over p is just log p. 1 over 1,000 natural log absolute value of p plus 1 over 1,000. What are we going to get for this? What are we going to say for that? Integral of 1 over 1,000 dp. Let's go ahead and do a u substitution quickly. If that's the case, then we'll say u is 1,000 minus p. du dp with respect to p is -1. So du is negative dp. Negative du is dp, which gives me 1 over u, and then dp is negative du equals kt plus c. So putting this aside, where are we at? We'll say that this is 1 over 1,000 log absolute p. This negative comes out in front, minus 1 over 1,000 integral 1 over u du the integral of 1 over u is log absolute u. 1 over 1,000 log p minus 1 over 1,000 log absolute u. This plus c is on the right side. That's good enough. What is u? U is 1,000 minus p. We're going to make that change. So we have 1 over 1,000 log p minus 1 over 1,000 log 1,000 minus p is kt plus c. Well, what can we do here? What can we do here? I certainly could factor out the 1 over 1,000. Then I have log p minus log 1,000 minus p. Equals kt plus c. And then what I'm going to do is I'm going to multiply both sides by 1,000. Multiply the left side by 1,000, multiply the right side by 1,000. If I do that, this 1,000 goes away, and the left-hand side simply becomes log p minus log 1,000 minus p. A 1,000 kt, k is a constant, c is a constant. 1,000 times a constant is still a constant, just a bigger one. 1,000 times c is just a bigger c. So that's nice. Then what do we do with that? we recognize that the difference of the logs is the log of the quotient. So, and I really can ignore these p's. Population is always positive. If the max is 1,000, 1,000 minus p is always positive. So at this point, I'm going to choose to ignore absolute values, recognizing these things are always positive. This is p over 1,000 minus p. Equals kt plus c. All right. Where do we go from here? What do we have? Our most recent line, natural log p over 1,000 minus p is kt plus c. The base of the natural log is e. E to this exponent, e to the kt plus c will be that argument. E to the kt plus c is p over 1,000 minus p. Then what? E to the kt times e to the c equals p over 1,000 minus p. E to the c is an arbitrary constant again. E is a number 2.718 to a c is just a different c. C e to the kt is p over 1,000 minus p. What were we given on the first page? We said p of 0 was 5 and p of 1 is 8. P of 0 is 5 and p of 1 is 8. Let's stick with the p of 0 is 5 part first here, which means when little t is 0, big P is 5. When little t is 0, big P is 5. What does that give me? CE to the k times 0 equals 5 over 1,000 minus 5. E to the 0 is 1, so we get C e to the 0, C times 1 equals 5 over 995. So C equals, what is 5 over 995? 1 over 199. So where we're at here, replacing the C with 1 over 199, we have 1 over 199 e to the kt equals P over 1,000 minus P. Now my next idea is P of 1 equals 8, which means when little t is 1, big P is 8. When little t is 1, big P is 8. Little t is 1 over 199. E to the k times 1 is P is 8 over 1,000 minus 8. So we get 1 over 199 e to the k equals 8 over 1,000 minus 8 over 992, which reduces to 1 over 124. So we get 1 over 199 e to the k equals 1 over 124. And of course, we want to solve this for k. So let's do that, multiplying both sides by 199 and then taking a log. So our last line was 1 over 199 e to the k equals 1 over 124. Multiply both sides by 199, and we get e to the k is 199 over 124. The next thing to do is take the natural log of both sides, natural log of e to the k is natural log 199 over 124. So k equals what? Natural log 199 over 124 is about 0.47302. It is positive. So we have some kind of a growth thing happening here rather than a decay thing happening here. So our previous line that we had sort of worked out was this, was 1 over 199 e to the kt is p over 1,000 minus p. We've actually solved the differential equation now. We have k is 0.47302, 1 over 199 e to the 0.47302 equals p over 1,000 minus p. At this point, with the t here, of course, e to the kt, 0.47302t, we can go back and we can look to see what our question was trying to ask. What were we getting at here? Find p of 2. So when t is 2, what is p, right? Find p of 2. Which means when little t is 2, find p. So we should be able to do that. When little t is 2, find big P. What do I have? I have 1 over 199 e to the 0.47302 times t, which is 2, equals p over 1,000 minus p. So here we'll see how good your calculator skills are. How good mine are. 1 over 199 times e to the 0.47302 times 2, and I'm getting 0.01294 on this side, equals p over 1,000 minus p. Multiplying both sides by 1,000 minus p gives me what? 12.94 minus 0.01294p equals p. Adding the 0.01294p to both sides, where does that get us? 12.94 equals 1.01294p. Divide both sides by 1.01294. And where does that put p? 12.94 divided by 1.01294. And what do we get for p of 2? We get 12.78. Remember, at time 0 it was 5, at time 1 it was 8, at time 2 it is 12.78. Now our maximum was how much? Our maximum was 1,000. So what was the other question that we were asked? How much time must pass before p is 900? So we're looking at our equation again, and we're going to set p equal to 900 and find out what t has to be. So our equation here is 1 over 199 e to the 0.47302 t equals p over 1,000 minus p. And this time we want p to be 900. So here's where we are. Well, if p is 900, where does that put us? 1 over 199 e to the 0.47302t equals 900 over 1,000 minus 900. So we have 1 over 199 e to the 0.47302t equals 900. 1,000 minus 900 is 100. That, of course, is just 9. 1 over 199 e to the 0.47302t is 9. Multiply both sides by 199. E to the 0.47302t is 9 times 199. E to the 0.47302t is a large number, 1791. Hit both sides with a natural log. So the natural log of e to the 0.47302t is natural log 1791. So we get 0.47302t. Natural log of 1791 is about 7.4905. Dividing both sides by 0.47302, what does that give me? An answer about 15.8. So to get to 900, it's going to take, if we're thinking days, about 15.8 days, from 0 to 5, and then eventually to 900 by the time we get to 15.8.